Hi students, welcome back. Now question number 9. Insert three numbers between 1 and 256 so that the resulting sequence is a geometric progression. We are going to insert three numbers in between 1 and 256. Let G1, G2, G3 be three numbers between 1 and 256 such that the first number is 1, the second is G1, third is G2 and the fourth number is G3 and the last is 256 is a geometric progression. Here this is the first term, and this will be second term, third term, fourth and fifth term. Okay, then we get A1 equal to 1, that is A equal to 1. And the last term is A5 is equal to 256. From this we can find R. That is A5 is equal to 256. That implies we know that A5 is AR raised to 4 equal to 256. Since A is equal to 1, we know that A equals 1. We substitute here, then we get R raised to 4 equal to 256. We take only real values, then we get R is equal to plus or minus 4. When A is equal to 1 and R equals 4, we get the second term A2. A2 is equal to G1. G1, that is G1 is second number. We are inserting G1, G2, G3. Then G1. G1 means second term. That is AR equals 1 into 4, get 4. Then the second number is G2. G2 is third term. AR square, that is 1 into 4 square, which will be equal to 16. And the third number is G3, which is equal to A4 equals AR raised to 3 equals 1 into 4 cube, we get 64. Similarly, when A is equal to 1 and R is equal to, R can take two values, that is R equal to 4 or R equal to minus 4. Next, when A is equal to 1, similarly, when A equal to 1 and R is equal to minus 4, same procedures. G1 is equal to, so second term equals AR. We get 1 into minus 4 equal to minus 4. G2 will be A3, that is AR square. 1 into minus 4 square, we get 16. And the third number G3 is equal to A4. AR cube equals 1 into minus 4 cube, we get 64, negative 64. Hence, we can insert 4, 16, 64 between 1 and 256 so that the resulting sequence are in GP, or we can insert minus 4, 16, minus 64 between 1 and 256 so that the resulting sequence are in GP. Okay, the next question. Question number 10. If AM and GM of two positive numbers A and B are 10 and 8 respectively, find the numbers. We know that arithmetic mean between two numbers A and b is a plus b by 2 and geometric mean between two numbers a and b is square root of ab. Here given arithmetic mean is equal to 10, that implies a plus b by 2 equals 10. That implies we get a plus b is equal to 20, equation number 1. And given that geometric mean is equal to 8, that implies GM between two numbers is root AB equals 8. That implies we get AB equals 64, equation number 2. We have an identity. We use a minus b whole square equal to a plus b whole square minus 4ab, which is equal to a plus b. We have a plus b as a plus b is equal to, from equation number 1, a plus b is 20. Then we can use here 20 square minus 4 times ab is, from equation number 2, it is 64, which is equal to 400 minus 256, which is equal to 144. Then a minus b is equal to root of 144, that is plus or minus 12, equation number 3. The first equation is a plus b is equal to 20 and the third equation is a minus b is equal to 12. Solve 1 and 3. This first equation is a plus b equal to 20 and the second one is the a minus b is equal to plus or minus 12 for a and b. First let us consider a plus b equal to 20. The second equation is a minus b is equal to positive 12. If we add 2a equals 32, we get a is equal to 16. Substitute in a plus b is equal to 20. When a is equal to 16, we get b is equal to 4. Or you take a plus b is equal to 20 and a minus b is equal to minus 12. So you add, we get 2a equals 8, a equals 4. When a is equal to 4, in a plus b equal to 20, we get 4 plus b equal to 20. That means b equal to 16. Thus, the required numbers a and b are 416 or 16:4 respectively. Okay. Next question is question number 11. Find the value of n so that a raised to n plus 1 plus b raised to n plus 1 divided by a raised to n plus b raised to n may be the GM between a and b. We know that solution, we know that the geometric mean between a and b is square root of ab. Find the value of n so that this may be the GM between a and b. If a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n is the geometric mean between a and b, that implies we get a raised to n plus 1 plus b raised to n plus 1 divided by a raised to n plus b raised to n is equal to root ab. That means a raised to n plus 1 plus b raised to n plus 1 divided by a raised to n plus b raised to n equal to a raised to 1 by 2 into b raised to 1 by 2 square root. That implies a raised to n plus 1 plus b raised to n plus 1 is equal to a raised to 1 by 2 into b raised to 1 by 2 whole into a raised to n plus b raised to n. That implies we get a raised to n plus 1 plus b raised to n plus 1 equal to a raised to n plus 1 by 2 is n plus 1 by 2 into b raised to 1 by 2 plus a raised to 1 by 2 plus b raised to n plus 1 by 2. That implies we get a raised to n plus 1 plus b raised to n plus 1 is equal to a raised to n plus 1 plus b raised to n plus 1 equal to we have a raised to n plus half b raised to 1 by 2 plus a raised to 1 by 2 into b raised to n plus 1 by 2. That implies a raised to n plus 1 minus a raised to n plus half b raised to 1 by 2 equals, in the RHS we have a raised to 1 by 2 b raised to n plus 1 by 2 minus b raised to n plus 1. From this, taking a raised to n plus 1 by 2, we get here a raised to 1 by 2 minus b raised to 1 by 2. Here if we take b raised to n plus 1 by 2, we get a raised to 1 by 2 again minus b raised to 1 by 2. That implies a raised to n plus 1 by 2 equals b raised to n plus 1 by 2. The next step will be a raised to n plus half equals b raised to n plus 1 by 2. That implies a raised to n plus 1 by 2 by b raised to n plus 1 by 2, which is equal to 1. We can write a by b whole raised to n plus 1 by 2 equals 1. This will happen when the power is equal to 0. There is anything raised to 0 is 1. Then we get n equals minus 1 by 2. Thus when n is equal to minus 1 by 2, a raised to n plus 1 plus b raised to n plus 1 divided by a raised to n plus b raised to n may be the GM between a and b. Okay. Thank you.